Okay, again, let's continue the discussion. We are talking about handbooks and reviewers that would help you. Additional support, complementary materials for your study. Okay. And again, we have the grading system for this course. As you can see on the right side, we have the course in section, which is CEA 2019. Subject, principles of steel design, subject code, CEE 6, and our schedule, and your instructor. Okay. Also in college, there are two kinds of teacher, professor and instructors. Okay. So in high school, we are called teacher. So in college, either you are called instructor or professor. So actually, I am an assistant professor in Taguig City University. Okay. So this is a record area of our attendance, recitation, quizzes, assignment, activities, projects, and we may have what more about problem solving. Okay, so it depends upon what will happen because our course has a portion problem solving, so not just the lecture part. So we also have a problem solving part, which is called laboratory in these policy standards and guidelines. Okay. So anyway, your teacher will also be the one to evaluate you, your performance, how you can manage to learn, how can you manage to prepare yourself, how you actually met the objectives of the course, which I already mentioned several slides ago. Okay, so you should be able to met the objectives of the course. Okay, so we have what 4 objectives in this particular course, PSD or Principle of Steel Design. Okay. So as an evaluator, we are acting like a judge or acting like a referee of a game. For example, boxing game or basketball game, a referee would finally make up a decision. Okay, so we are doing our part like that, and I'm trying my best to be fair enough to each and everyone, so that I don't have any guilt. No, actually, I don't have, because in my mind, I am doing it fairly for everyone. That's why I do not remember. I do not remember those students who got failing grade, who got incomplete, who got passing grade, who got high grades, who got any type of grade. I do not remember because I do not need to. I am just what? Evaluating you, each and every one of you, fairly. Because if I do it personally, I may make favoritism. I don't want to make favoritism. So that's why I don't need to remember who got the highest grades, who got the lowest grades, who got anything. I don't remember because I want to avoid favoritism. Okay? So although that is my way of being fair, because even though we are a judge, we are also human and susceptible to errors. I want to avoid errors. Okay. So and before we answer this problem solving, or while we are showing you this problem solving for this particular video, I would like to give you the meaning, the definition of the title of this course. Principle of steel design. What do you mean by principle? Principle is what? A collection of ideas, truths, proposal, theories, concept, which systematically put together in order to give substantial meaning. Can be used either in designing and analyzing something. Okay, so those important guidance. Okay, so those principles will guide us, will give us an insight. Okay, to be able to properly design, because designing and analyzing is becoming scientific, but not yet totally scientific. Meaning, there still have an area for art. Okay, just like a judge decision-making process, there is an area for artistry and personal choice. No, there's a personal choice. Decision-making sometimes has a part versus personal. Okay. Okay, so that is supposed to be the same with design and analysis. But even as advanced as today, we still have an art portion of design. Meaning, each and every engineer has different approach to the design. We will teach you, we will give you, we will lecture on it, we will discuss it, we will explain it. But afterwards, you will have your own approach. You will pick up your own approach depending on your personal personal choices. Okay, you will have your personal choices. Why you are doing that? Why you are doing this? Okay, so that's why still we have differences between engineers. Okay, their design may equally satisfy the conditions, but they may be different, or really different, or far different from one another. Okay, so I would like to expand on that, because design is different from analysis. The word design, as used in this context, in civil engineering context, means it is designed for strength. It is designed for design. In terms of civil engineering, actually, there are several types of design. Design for strength, design for serviceability, design for constructability, design for economy, design for stability, right? Design for ductility. Okay? There are several areas to the design. Okay. And the most important one is design for strength. Okay, so design for strength, we are going to look into the design by which an element strength could be able to withstand, okay, by what? By specifying the dimension. That is what we call design. We have a given load, we have a given material, we have a given standard codes, and we are asked to find what dimension or what alternative material, okay? What sizes of those materials involved, okay, is or are necessary to be able to withstand the load. Okay. So that is what we call design. We are solving, we are actually computing the size, the dimension of the material. Okay. What about analysis? Analysis is when we are given the dimension, and we are asked if this dimension of a particular material would be able to satisfy the required strength. Okay? So what we are going to do is to calculate the material, calculate the strength emanating from the dimension given and compare it to the required strength. So is this size of the material give greater strength than is required by the condition, or this dimension of material gives us lower amount of strength than the requirement? Okay. That is the problem of analysis. That is what we mean by analysis. Okay? And therefore, we are actually doing the same thing, but in reverse order. So, for example, design, we don't have the dimension. We have the material and we have the specification of material. Okay? The stress allowed by the material, the allowable stress that the material can handle. We know it because we know the material. We can use that allowable stress of the material and use that in our computation and find out the dimension. Okay, that is the design. So we can find the dimension. Now we have the dimension here. We have the dimension, and we are going to find out what is the allowed strength. And after finding out the allowed strength, we can now pick a type of material that can withstand that strength. Okay? So that is analysis. Or if there is already a selected type of material, we can just compare the material's allowable strength to the calculated strength given the dimension. So is it greater than or less than? So we can decide. That is what we mean by analysis and design in the context of any design courses. Okay. Any design courses, whether it is civil engineering, mechanical engineering, because mechanical engineering also designs machines, size of machine. Okay. While civil engineering designs For example, bridge, size of bridge, element, size of building elements. While in mechanical engineering, we are designing size of machine elements, size of machine components. Okay? So, similar. Okay? But not in the context of, for example, computer engineering or in the context of industrial engineering. So, different discipline will have different context when we are talking of design and analysis. Okay. For example, in instrumentation and control, analysis and synthesis rather than analysis and design. So synthesis is actually related to design. Okay? Related to design. But there might be another meaning. So they are just related. So synthesis and analysis, they are opposite in meaning in the context of instrumentation and control engineering. Okay? Or in mechatronics engineering. Okay? So what we are talking about here is design of steel. So we are talking of principle of steel design. We are going to design a steel component, a steel element, a steel assembly, a steel frame that could be used as a structure. So design for strength. Design for strength has to approach analysis or design. Okay? What about steel? So we already defined what do we mean by principle, what do we mean by design. Now, what do we mean by steel? Steel is a very technical word when we are talking of engineering, particularly mechanical, civil, electrical. So, because steel is a construction material. Okay? And actually, the number 2 most used, popularly used, abundantly used, number 2, okay, is steel. Okay? Because of its characteristic. So, what do we mean by steel? Let us take a look. We have an extra slide here. We have an extra slide. Oh. Okay, this what do we mean by steel? Steel is defined as a combination of iron and a small amount of carbon, usually less than 1%. Okay? And if you put 0.2% or 0.4%, that is actually good amount of carbon. But if you put 0% of carbon, we cannot call it steel. That is only iron. So steel is not an element. What is steel, therefore, is an alloy wherein it is a combination of an iron element and a carbon element. Okay? With very specific mix, with very specific recipe. Very small part of carbon only. Carbon can be up to 2%. It can be up to 2%, but the characteristic is not good. If you put more carbon, the characteristic will not get better. It may even get worse. That's why there is a limit. The best characteristic is only up to 1%. And you can what? You can experiment. There are plenty of experiments and they found out 0.2%, very good amount of carbon. Meaning the characteristic creates more advantages rather than disadvantages. Okay? It also contains small percentages of some other elements. Okay, like what? But less than 1%. So carbon is the next one, but less than 1% for carbon. But if we are talking of what? Stainless steel, so carbon is, for example, 1%, but we have what? For example, molybdenum or chromium. Chromium is usually used in stainless steel. That is still a type. Stainless steel is a type of steel, but stainless steel is not susceptible to corrosion. It will corrode, but very, very slow. Okay? And maybe that is because of presence of chromium and vanadium. Chromium, vanadium, and sometimes molybdenum and so on. Okay? So about 5%, 10%, 7%, something like that. 10% chromium. So very specific amount, very specific recipe. Recipe meaning proportion. Proportion meaning percentages. How much percent of vanadium? How much percent of chromium? Okay. Although some steel has been made for at least 2,300 years, there was really no economical production method available until the middle of 19th century. The use of steel is old enough. Okay? So this is what I meant by defining design. We have design for strength, design for serviceability, design for durability, design for constructability, design for economy, and design for stability. Okay. So we are only going to talk about design for strength. Okay. In this specific course, we are going to use the definition of AISC 303-16. What do you mean by that? AISC is American Institute for Steel Construction, document 303-16, meaning 2016. Okay? Structural steel is an steel element of the structural frame that are shown and sized in the structural design documents, essential to support the design loads and described as ... That is what we mean by structural steel. Structural steel meaning those type of steel that could be used to support a load. That is what we mean by structural. It supports a load. Okay? Those elements and components that do not support a load, we do not call it structural component. We do not call it structural steel or structural element. Okay? Okay? So they support a load, that's why we call it structural element. And since we are designing principle of structural design, we want our design to carry some load, to satisfy condition of loadings. Okay? So that's why, in a sense, it is actually structural steel. We are not just designing something that would not support any load. If that component will not support a load, why design it? Just randomly pick, arbitrarily pick a type of steel, and that's all. Okay? What do you mean by that? If you are asked to make what? If you are asked to make an alphabet suitable for what? For writing down the family name and address, and put those in our gate, okay, in the gate of your residence, okay, so that you can be recognized by what? Postman. Deliveries, you can easier be recognized by the delivery because you have surname and address at your gate, and you are asked to do it, the writings in terms of what? By using steel. By using steel and welding. Do I need to design the structure? I need to design the shape, but not support a load. It does not need to support a load because that is, for example, Z, as in ZANTUA. Z, letter Z. It does not support a load. I will just weld it to the gate. Okay? Take note of the difference. We don't need to design it. Just pick any type of steel, beautiful enough or clear enough so that the delivery or the postman could be able to recognize it. Okay? And just shape it like a ZANTUA. That is your family name. Okay? And then weld it or bolt it or rivet it to the gate. Okay? We don't need any design. The word design gives us a clue that we are actually using structural steel. Okay? So this is the definition by the AISC. So we are not choosing the dictionary definition if we are talking about technical terms specific to this. So we are using, rather than dictionary, we are using codes to find out the definition. Okay, so this is the code 303-16. So it defines structural steel as an element of the structural frame that are shown in size in the structural design document. It is specified. It is specified in the design document. Therefore, that is supposed to be a structural element, and that element must be essential to support the design load. That is the key word there. Essential to support a load. Okay, and describe as. So describe as. So that is the name of the part. So this can be described as what? Bracing, can be described as beam, can be described as cable, can be described. So there are plenty of things. And actually, in this code, in this document, AIEC 303-16, the definition of structural steel is actually the whole page, the whole one page. Okay? Because there are plenty of types of names given to it. Struts, rods, what else? Trusses, okay? So there are plenty. Column, okay? Link, okay? Brackets, so there are plenty. Okay? That's why it covers the whole page. But I just put what? Dot. Because that ends the important thing. The important thing is it is designed, it is sized, it is shown in the document, and it carries a load. Those are the important keywords. Okay? Okay, so meaning we can combine all this concept and definition to give us an idea what we are talking about when we say principle of steel design. Okay? What are we talking about when we are saying principle of steel design? So that means we are talking about those things. Okay? Let me go back to this. Okay. So you are asked in this problem to search for all the new CMO for civil engineering. So in addition, you have to describe in your own words the differences between the new and old CMO with respect to this course, with respect to this principle of steel design course. Number 2, you have to compare all the new specification and references. Okay. And number 3, what can you say about the coverage, the topics covered, okay, for all the new CMO? Take a look and say something, brief observation. You have to be brief. It could be one sentence. Okay? Number 4, state your opinion about the grading system. And I would be posting a link so that you can submit your answers. Okay. Oh, this is for PSD. So I borrowed the time for PSD, and later on I will pay the time from PSD. I will put it back to PRPC. So let us do it today because there's an incident that negatively impacted my. So this document is not actually complete, but I have to use it in order for us not to waste our time. Okay. Any question? Any question? I would give you 30 seconds. There are any question, I would like to answer it. So thank you. You can expect this to be uploaded in this playlist under this channel. I would create a new playlist specifically for this. So you can still go back and take a look, review, watch the old curriculum lectures. So there are no questions. There are not. There are none. Again, thank you, and see you next subject or next course or next meeting. Okay.
Thank you po, sir.
Okay. Thank you again. This is Dr. EYPEI.
Thank you, sir.
Engineering for Nation Building.